There we go.
Start.
All right. Good afternoon, everyone, or morning, wherever you may be. My name is David Schmidt, and I will be the facilitator for today's session, which is titled GMNS and Multimodal Assignment Practical Agency Experience. GMNS stands for General Modeling Network Specification. We'll let you know that there's a poll being that you should be seeing a poll pop up and about various questions about the topics and issues covered in this presentation. So please feel free to fill that poll when you get a chance. Next slide, please. This session builds upon two previous sessions held recently about GMNS. The first session was held in May 2026 and introduced GMNS. A second session was held in June that presented an example of using GMNS for a multimodal accessibility analysis. Today's session will present two additional examples where GMNS was used for multimodal and multi-resolution studies. And you can see that we have one in October using building networks with Network Wrangler. Next slide, please. I want to spend a minute refreshing your knowledge of GMNS. So GMNS, which again stands for General Modeling Network Specification, enables data to be used between macro, meso, and micro scale models and processes. The goal is to make multimodal and multi-resolution analysis quicker and easier by understanding the network attributes across modes and resolutions. Next slide, please. This session will refer to GMNS Plus, which allows GMNS networks to be used with common software and data sources. It also goes a bit deeper into multi-resolution attributes and expands the number of multimodal modes. Next slide. Today's session will include two presentations. The first will discuss a multi-resolution analysis recently used in the Northern Virginia area. Dr. Azkan Golami will be given this presentation. The second presentation will be given by Guy Rousseau and Mohammed Abbasi and discuss how GMNS was used to replicate the existing highway assignment process. After the second presentation, we'll have a brief question and answer session. We'll be reviewing the chat session during the presentation, so if you have a question, please enter in the chat and we'll get to it. Next slide, please. And then after today's session, you're invited to join the Zephyr Lounge to discuss the topics we're presenting today. We have folks knowledgeable about GMNS at this in the lounge here, the forum. Use the QR code or the website here to join the forum immediately after today's session. We'll repeat the slide during our Q&A session, so you don't have to worry about saving the QR code or the link right now. All right. With that, I'd like to introduce Dr. Ajkan. So, Joe, if you can get that presentation up and going. Dr. Ajkan is a transportation modeling professional with experience in regional and corridor level travel demand modeling, including development, calibration, validation, and large-scale travel models, and uses tools such as Cube, Visum, Transcad, and Dynamic. Dr. Ajkan is a licensed PE, professional engineer in multiple states, and is a certified professional traffic operations engineer. So, Dr. Ajkan, I'll turn the floor over to you.
Thank you. Joe, I think the presentation is not shared yet. I think we got it. Thank you. Hello, everyone. Good afternoon or good morning if you are in the West Coast. The topic of the presentation is NVTA use case of the GMNS for the travel demand model that we have. Next slide, please. So just giving you a little bit of a background about NVTA, what we envision or what is our goal for a successful transportation system in the north of Virginia is having a transportation system that is safe, sustainable, and efficient. And our jurisdiction consists of 5 cities and 4 counties. Can you all hear me well?
Yes.
Yes.
Okay, perfect. Thank you. And then for achieving that goal, one critical task is actually communicating with all these different jurisdictions, both in a high level in terms of planning and also in terms of analytics and sharing data and making sure the goals of and objectives of the program are met. Next slide, please. So we have a funding program and also a long-range plan. In the long-range plan, we have the travel demand model that is the basis to actually calculate performance measure for projects and rank them, and then eventually make funding decisions to see which one needs to be funded in our 6-year program that happens every 2 years. Recently, in July, we adopted the 6-year program 2026 to 2031, and we are still now updating our transaction long-range plan and also the travel demand model. Next slide, please. In terms of the project selection process, we have several components and consideration, but the most relevant to the today presentation is the quantitative analysis that has 3 components. The most critical that we look at by law is the CRRC, congestion reduction relative to cost. We look at how much of delay reduction we get for each project from an interim year to the from the project completion to the horizon year, and then based on that, how much divided by cost, and then we rank that, and that has a critical impact on our funding decision, which projects to fund. But we also enrich that decision with transaction project ranking that I will get to it, which is looking at 10 different performance measures that are directly output of the travel demand model, which is a multi-resolution modeling, both macro and meso, and eventually in the long term benefit, we want to make sure that all the region benefit from the revenues that they have brought in a long run. So if in one cycle we are not very well balanced, we try to be balanced in a long term. So in the next slide, thank you, Joe, in the CRRC, previous one. Thank you. In the CRRC by law, we look at the congestion reduction, and we see how much of delay is reduced based on how much of the cost of the project is, and then we rank them, and then again we look at 10 performance measure in the next slide that are weighted. So they look at different components of delay for highway, for transit. We look at accessibility. We look at how much of a project contribute to having a more or safer transportation system, vehicle emissions, and transportation redundancy. So in most of these measures, we needed a mesoscopic model that the travel time is beyond like a 15 minutes time window instead of a couple of hours or period, which is mostly for the macro model. So in the next slide, we have 21 projects adopted in our very recent cycle. So the CRRC ranking is shown here, but also the transaction ranking are also considered in addition to all other considerations to eventually decide that out of 27 applications, we decided to fund 21 based on defensible evidence that these one benefit the jurisdiction the most. So in the next slide, as you can see, this funding allocation for this cycle, it has interestingly funded 9 bike and ped projects, but if looking at money, the roadway projects are way more than half of the total amount of $776 million that has been allocated. And you can see that we try to be modally balanced and also geographically balanced in the map, because every jurisdiction is contributing to the revenue that needs to go back for project funding. In the next slide, the travel demand model that we have is shown. The 2 green boxes basically are the Metropolitan Washington Council of Government travel demand model that we have adopted it for our use, but we have enhanced the mode choice to look at the emerging technology like TNC, transportation network companies, and connected and automated vehicles, but more importantly, we have coupled this model with the meso model with the help of ASU team to look at the speed data from in-race count data and do a wide range of analysis that most of it is facilitated actually by the capability of GMNS to put that network that we get from the MW cog to put it in the right format for the DTA light and GMNS assignment. And eventually we calculate most of those performance measures from the meso model output. Next slide, please. So there are a lot of challenges in building the model specifications in networks. So I have been doing network modeling and optimization for many years, every programming language from network X, from using GIS data, creating a graph. Almost, I would say, every researcher or practitioner might use it differently, and that's the same among the software from Cube, from Visum, from Transcat. And then in most cases, like what we have in Northern Virginia, you have multiple network, each of them representing one mode of travel, and most of the travels might have a different segments or different mode based on the user needs, and merging that and aggregating that to ensure that reflects and it is consistent is something that I think this GMNS is offering, but most importantly, it is also very flexible and still growing. So in the next slide, as you can see here, based on the model that you have, if it is a micro simulation, a lot of detailed information about an intersection from the control type, from the movement, turning movements, and other informations might be coded. If it is a macro model, probably less of those data need to be coded. As I mentioned, I have seen this GMNS network format growing, and in here the link to the growing community on GitHub is available, that is being used by practitioners from MPOs, cities, and US DOTs. Next slide, please. In terms of the data structure, no matter you have a shape file, you have a matrix file from Q, from Transcat, eventually what you get for the GMNS is a kind of a standard format of the CSVs. The most critical ones are the node and link relationship. In the node, obviously, you have always a lat and long for the point data, and you have this node ID that is used in the from to node field in the link. And just based on this simple relationship or adjacency, you can visualize this GMNS in any ArcGIS software, including QGIS, uh, open source software. Next slide, please. But it goes well beyond the looking at a static data like we have in a shapefile. So for a GMNS, lots of user-defined fields also can be created, and based on the resolution of the model, if someone is doing the micro simulation, if we have the agents, if we have the capacity changing in different periods, or traversing a link is allowed in one period but not in another period, or who is using different segments of a transportation system, all of that can be coded into GMNS in addition to the linear reference capability, where you may have that milepost of even representing events if you are doing safety analysis or want to tag some location to this GMNS. But on top of all of this, in our NVTA experience with ASU, we have been using our GMNS model to actually tag index data, count data for our model validation. So basically, it offers a lot of details based on what we have been using it for. Next slide, please. And then as far as the segment and lane relationship goes, uh, as opposed to a macro model in here, you can even specify every lane, the way that they are functioning, the movement, and even for every individual links, different segments can be represented if they are uh, reaching to a destination where you have movements or the number of links changes, all of that can be tracked when coding the network. Next slide, please. And the same is with the node data. Either it is the control type of a node data or the movement of the users that are making their turns in an intersection, that all can be coded in the GMNS data format. Next slide, please. So as I mentioned, in the very basic representing of the network based on GMNS, you can have that node and link file and easily visualize what you have got in QGIS or other GIS platform like ArcGIS Pro. But for the needs of analysis and travel demand modeling, basically it offers a lot of other capability to kind of define your network and then have that as a clean start to input for DTA Lite or other complex traffic assignments. So basically, you get the node and link, and then you can have that setting of looking at the demand for every period, users, and all other detailed information. For our case, we have been having all this VDF alpha and beta parameters for every period, that all of that complexity has been taken care of in this uh, kind of clean data structure. Next slide, please. And then we have been also, in addition to our cube model, having that transit component in our GMNS network, in addition to our highway network. What we have got from our cube model in the text format with some sort of a different format, but eventually we have that node and link relationship set up. I mean, the node ID is reflected in the link file and also having all those information related to the service for the transit component. Next slide, please. And then, as I mentioned, we are consisting of 4 counties, 5 cities, but very many transit operators in the system. That just think of even getting the ridership data for data validation, looking at network expansion and many other information, and working with all these different agencies really necessitates having a streamlined process that every cycle can be updated and adopted, and without having like a ad hoc format network structure. So I think that's what has been offering GMNS to our team during this previous model cycle and this model cycle that is ongoing still. Next slide, please. And just as user-friendly as a cube model that provides the assignment as an output, you can visualize not only the input that when you get it from other platform, but also the output on a GMNS network that you can also look at what is the volume or even travel time or congestion if you're doing a highway. And then in the next slide, you can see the comparison between the ridership and all of the, we have been trying that our macro and meso and ground truth information, which are the count and speed data from InReach. The count mostly comes from the MW cog, telling the same story. And you can see in here some of the output of our model validation effort. Next slide, please. And I think this is the last slide, as I mentioned. So working with different platforms, for us, the macro model coming from the cube, our validations coming from third-party data providers like InReach, or even our transit from having a GTFS format, working with all of this. I think this community that is using and kind of developing and growing the GMNS data format is trying to kind of standardize that task and data structure. That would be something that in the future or even right now, when you are given a GMNS data format, you know what to expect or what to look for, and all of those Python packages that reads these shape files and create those CSV files are already well developed. I have seen and worked with some of the ASU libraries, and I think this community using and growing this GMNS data format is growing, and thank you for your attendance.
Thank you, Ajkan. As we get the next presentation lined up, I just want to remind you, everyone, if they have questions, please enter them in the question and answer chat, which you can see at the bottom toolbar. There's specifically a Q&A mechanism, so we can incorporate your questions into the Q&A session after our next presentation. So our next speakers are Guy Rousseau and Mohammed Abbasi. So Guy Rousseau is the Transportation Models and Travel Surveys Manager for the Atlanta Region Commissions, ARC, which is the MPO for Atlanta. He joined ARC in 1998, and he's responsible for model development activities and travel surveys. Mohammed Abbasi is a doctoral researcher at Arizona State University, specializing in scalable transportation modeling and data analysis. So welcome, and Guy, I'll let you hand it off.
All right, thank you, Dave. So we're going to be talking about reproducing a regional assignment workflow via GMNS, being the one from the Atlanta Regional Commission. I'm going to show you what we tested, what we're able to reproduce, and what still needs some reviews from my perspective or the ARC perspective. Next slide. So the goal here is to go from a set of published files, because literally, in the spirit of total transparency, the entire model of the Atlanta Regional Commission is available online, as you can see on this slide here, available for download, everything, input, outputs, executables, everything. In this, again, the spirit of total transparency, making it available for others to use in various projects in the region. It is a large network. It's a large region. We go from basically, if you go north to south, east to west, it's 80 miles or roughly 400 square miles for a region. We'll go as far west as the state of Alabama. We've got 21 counties. Now, counties are small in Georgia, sounds like a lot, but the population is well over 6 million people, as far as just to get a feel for an order of magnitude of the Atlanta region. It is a multimodal activity-based model. It is the official production model currently for everything, tip amendment, MTP plan amendments, air quality emissions, conformity determinations, everything. So basically every project, or it's a GDOT project, City of Atlanta, any project starts with getting the demand from the ARC trial demand model. So it is activity-based model. We're currently in the process of transitioning over to ActivitySim, not quite completed yet, but we're getting there. We're also updating our travel surveys currently, household travel surveys and transit on board surveys. So lots going on in the region. And again, back to the model in general, it's got quite a few zones, and we like to have many. And we're not into microzones yet, but we have a lot of zones just to make sure we properly are presenting our travel in the region. Next slide. So in our case, we're finding out that we need more than just a network export. It's one thing to export your network via GMNS. And oh, by the way, that's one of our main goals, is to be a bit more GMNS compliant, for lack of a better term. So there's all kinds of very helpful specifications via GMNS. So this is a way for us to accomplish many goals. One being to finally get into a fully compliant GMNS approach, but also the ultimate goal is to get into regional DTA with an open source program being DTA Lite. So this is basically the goal of this entire project. So starting with the network, obviously, and have the proper representation, the network topology. Then into looking at this, that is the supply side of things, everything from, number of lanes, time of day periods, speeds and area type, facility type, that's all well represented and accounted for. And then the travel behavior aspect and the cost aspect via volume delay functions, value of time, and tolls by class, vehicle class. So it's kind of a sophisticated approach. And then again, time of day periods. We have some restrictions associated with roadway networks in the region without getting into the details. And then as far as validation, so for this exercise, we're focusing on the AM peak. And so far so good, I will say. So next slide. So the full model is the entire goal. The ultimate goal is to transfer the entire model with all time of day periods and through GMNS into regional DTA eventually. And that calls upon, looking at the demand, how we generate the demand coming out of the ABM and going through static traffic assignment. Of course, at this point, it's still static traffic assignment. So what this test covered, we covered, as I said before, the AM peak only. And we looked at the main thing was the handoff or the exchange going from the CODA network into GMNS and then validate certain corridor level, doing some corridor level validation, looking at congested speeds, compare that with INRIX as well. Next slide. So when you look at it from a static traffic assignment perspective, it is technically sophisticated as far as that's concerned at ARC, meaning, and I have it up on this slide here, we use a BPR, volume delay functions using the biconjugate Frank-Wolf. Convergence, we try to be pretty tight about it, so we have a stable assignment. So criteria is listed here for relative gap. Route choice based on generalized costs and formulation is indicated here. And then we have a variety of assignment classes. They're all listed on the slide as well. And then the ultimate goal is to properly reflect congested travel speed, compare that with INRIX data, another data set. And then that's where the handoff takes shape into via GMNS into the ultimately what will be the regional DTA. Next slide. And I believe that's where I get to turn it over to Mohammed. So Mohammed, take it away.
Thank you, Guy. Um, as Guy explained, we selected ARC because it's publicly available, and we wanted to show that GMNS can serve as an exchange layer to allow us to reuse a tool chain and allow us to test open source. We're not replacing the ARC source model, but we are allowing to using other tools at the same time. So the process here we selected, we start from the ARC source and then we convert them to a GMNS package. The important thing is we are not just converting directly to GMNS package. It is important to carry the meaning of the model. That meaning can include the ID, direction, access, tolls, and all the artifacts that are within the ARC source model. That then we can use the external tools and external data set. We selected CBI, which stands for Congestion and Bottleneck Identification. It's a software tool set from FHWA. And for the data set, we selected INRIX speed data set that includes the traffic message channel as identification, as a identifier, and has a speed profile for different days. For these application, we selected the whole month of October. And after that, that allows us to adjust our VDF parameters to better represent the speed, the observed speed, so we can then go to the assignment. Our ultimate goal in the assignment is to go to the regional DTA, but here only we have the static as the first step before going to the regional. Next slide, please. In using the external data set, the INRIX that I mentioned, we need to map those data accurately to our converted network from ARC. Here comes another tool that allowed us to match those INRIX data to our ARC network model. So we downloaded the data that includes 17,000 TMC geometry over 3 years, and which comes from the 4,000 INRIX source. And we categorize them. We could match them into 375 corridors. That led us to have an auditable data source that include the observed speed, daily observed speed, for 375 corridors. Can you go next slide, please? So having these TMC data, INRIX speed data, allowed us to reuse the FHWA CBI tool for identifying the bottleneck and congestion. The CBI tool defines a free flow region and defines a congestion region. As you can see on the figures here, the top green highlight shows the free flow regime. Below that, it shows identify the episode of congestion. Within those episodes, it identifies the start, critical point, and the end of the congestion before screening or preparing it for calibration or adjusting a VDF parameter. We use the output of this model to adjust our VDF parameters and define a boundary for our congestion and based on the observed speed profile. Next slide, please. Then in the next step, we try to reuse open source traffic assignment tool. We use TAP Lite here that have a static traffic assignment. For these application, we converted the ARC source, which is a cube exported shapefile with ARC identifier and conventions. We created a customized Python version for this pre-processing that help us to carry the ARC fields into a node layer, link layer, settings, and demand, and some other reference field that have the capture the complexity of ARC model. For example, here, ARC has a prohibit and tall lookups for different modes. We transfer them into allowed use plus a toll cost into the generalized cost, so that we could capture how ARC model different modes and variable toll costs during the day. Next slide, please. So the completed run scale includes 6,000 centroids, 66,000 nodes, and 146,000 links. And out of the 12 nodes, we only model 7 of them here, 4 AM peak. That includes 3 million AM trips. It preserved the ARC VDF meaning, class cost, and the toll semantics. That all happened because we could all transfer all of those into the GMNS exchange layer. And for the result, we got a comparable class volume, reproduced closely, HOV only, access is exact, and SOV is close. You're working to get other modes converted and transferred to the model so we can have a full complete on this. Next slide, please. The ultimate goal and the objective of this presentation is that the agency can keeps its established source of record and convention. A GMNS exchange package can carry the meaning of the model into exchange layer that allow us to use across different tools. The benefit is we can have the repeatability to repeat the same tool chain with different tools for validation. We can audit this um, conventions through other QA tools. We can have a different choice of tools. We can test open source tools that we do not have the capability or functionality in-house. So it allows us to have a lower switching cost to other functionality and capability. Thank you.
Yeah, thank you, Guy and Mohammed. Really appreciate that. Wanted to just before we get to Q&A, wanted to remind you to, join us in the Zephyr Lounge, and I'll remind that after our Q&A session. Please put any questions that you have in the Q&A chat box if you can. There's a specific Q&A tool at the bottom of your Zoom screen. We've already gotten a couple questions via that way as well. I've got a couple questions myself. The one is we have one question come in just regarding GMNS, and just to clarify, GMNS is a network specification. It's not a model. It's not a piece of software. It's just a way of exchanging information between different pieces of software. So we've had that question come to us. Question for I'll start with Ashkan. Can you talk about how long it took you? You talked about the process of using the network information between two different resolutions. How can you talk just in high level terms how long it took to set up that process and how long it takes to actually run that exchange process?
Well, I think the exchange process for our regional model, it's quick. So probably less than, I think less than 5 minutes. So the GMNS rollover there in terms of like the computational, that's a very fast reading and creating that format. But in terms of when it does the actual assignment, when it has this information, it depends on the regional. In some of our setting, it takes few hours. In other ones that we have sub area for individual projects, again, it comes down to about 10 minutes or so. So it depends on we are running regional or sub area project, a specific thing. But the GMNS step that is just exchanging that information from our shapefile that are coming from Cube, that's also fast.
Okay. Guy and Mohammed, I'll ask you the same question. Just generally, how long does it take to set up that process and actually execute the data exchange? But if you can talk about setting it up, setup time and
So
first.
yeah, so I believe that information was on some of the slides, but it's essentially if you were to compare that to, let's say, running the regional tri-domain model per se, there's definitely some time savings here. And not only that, but in my mind, one of our main goal was to be quote unquote, or to demonstrate GMNS compliance, because GMNS is a great way to have their standard set of network specifications for coding. So that kind of facilitates to us that whole process of network coding, with the goal again to take this all the way out to regional DTA. And then in this case here, it was a test for the AM peak, but it provides some good time savings, I would say.
Okay. Um, another question to both of you before open up the floor. We're getting some questions come in on the chat box, but one question to both of you. Did you have to make the case to your management and colleagues about using GMNS for the process that you used? So I'll start again with Ajkan. If there's how did you make the case to use GMNS for the process that you presented?
I think the motivation started before even using the GMNS, where our delayed performance functions needed high resolution. So at the first place in the previous cycle, before I joined the team, they had made this decision to go beyond macro modeling. So I think the consultant at the time that worked on the meso model with Cambridge Systematic was ASU team, and they make heavy use of GMNS, and I see that in our module and setting, we have all the Python for transformation and everything. So it seems like as soon as we made the decision that we want to go with Meso and ASU team, then the GMNS was the default
Okay.
kind of data transfer protocol.
All right. Thanks. Guy and Mohammed, same question. How did you make the case to use GMNS for the for the work that you presented?
Right. Good question. Thanks for asking, Dave. So the business case here is basically be able to demonstrate that we could leverage open source tools. So we use open source data. The model is basically wide open and transparent. But we want to take that a step further, right? Looking at the network coding environment, make sure that it is ultimately quote unquote GMNS compliant. What I mean by that is to use a standard set of network specifications that can then be replicated into another platform. So in terms of data exchange, and I'm sorry. Sorry about that. And it's ultimately is to get into regional DTA, and because we've been looking to regional DTA for quite some time. We have a large network, obviously, but in this case here, it's incremental, meaning we're looking at the AM peak one time of day at a time. Eventually, it'll be the entire um, duration, all time of the periods, and then look at certain corridors, make sure that at the corridor level it validates well, and so this is not a race. This is we go step by step incrementally. And the ultimate goal is regional DTA with DTA Lite.
Got it. Thanks. I'll go through the audience questions now, so I'll put everybody on their toes. So first question with Guy and Mohammed is your presentation. It was mentioned that in your presentation that there's a process to move toward activity sim. And so the question is then what was the reason for considering GMNS?
So activity sim is mostly for the demand side of the entire modeling equation, right? So on the supply side of things, networks and all that good stuff, my preference was to go via GMNS. Again, at the risk of repeating myself, it's a standard set of specifications, but it also facilitates the transition into regional DTA. So it's one thing to get to activity sim on the demand side of things. The ultimate goal is to get into regional DTA. So GMNS is a kind of a data exchange tool that allows us to step our way through away from static traffic assignment into regional DTA over time.
Thanks. And just one other question specifically for ARC is and just to confirm or just to reiterate, the ARC network conversion, that was a macro level conversion AM peak period only, correct?
Yes, that's correct. Yes, yes. And then eventually, once you have that in place, fully tested, thoroughly tested, and then replicable and all that, and be able to audit the entire work, then we take that into other time of day periods. But it's a very incremental, careful way to step into, the ultimate goal, dream being regional DTA in an open source platform with a good set of networks standardized based on GMNS.
Okay. We're getting some questions about GMNS in general. So I might invite some of our panelists, Scott and Jojon to join here. The general question is one question is can you go back the other way? So, and going from can you talk about the details in the micro model, and can you put those back into your regional model platforms when you're working with GMNS?
So as far as we're concerned, we're not quite there yet. We're not
Okay.
quite to the point where we can work our way backwards through the process. But I think ultimately is to have a faithful representation from A to Z of the entire network procedures, coding, representation networks via GMNS. But I'll leave
So
it
Yeah,
others.
Scott or Simon, if you want to jump in. And Scott, you're on mute.
Yeah, well, one of the points of GMNS was to bridge that gap where you can start with nodes and links, and then they're integrated with the more detailed data elements. So at that point, we're already one step ahead of the game in terms of making sure those are logically consistent. Uh, Now we've not done things like deriving VDFs from simulation results. That's more modeling. That's more in the modeling realm.
And if I could add, because I think this is relevant, to give a higher level um, view of sort of this GMNS series. So GMNS is a network standard, and it's agnostic to whether it's micro, meso, or macro in terms of its standard. So it's a network standard. And then what we're talking about today is like using GMNS as a standard intermediate format to go from, an agency's model network to GMNS, and then to be able to plug it into tools that support GMNS. So in this case, DTA Lite supports GMNS. And so that's sort of right now, this is focused on this one direction situation, but the next learning session I think it was October.
October.
Yes, is basically sort of the other piece. Like it's going to focus on Network Wrangler, which is a tool set for building networks from scratch, for manipulating networks. And basically, like in that paradigm, the networks are always in a standard format. They don't start in a proprietary format. They start in a standard network format like GMNS, and then they export to the proprietary formats. And so hopefully that kind of helps to like balance how these things are all fitting together. And it's all obviously, of course, like a work in progress, but but that's the idea.
Oh,
So so in theory, you could because it's not is people a lot of folks have a network, but also there's a lot, I think for me, I think there's a lot of interest in having tools to build the networks, to add data from other sources and make those networks more complete for these purposes. And so that's kind of the other piece of the puzzle. Hopefully that clarifies.
thanks. Yeah,
I'm
no, yeah.
confused more.
No, no, that was great, Lisa. And folks are asking about if they use different types of software than the ones that were described in these presentations. They can still incorporate GMNS in their environment, right, Lisa?
Yeah, I mean, GMNS is like a data standard, and I mean, and ideally, like in the long term, if GMNS becomes um, like more viable, then the hope is that commercial products and commercial vendors could start to support it directly, so that we're not doing these conversion steps. But it's right now it's in early stages, and so we understand that that might be a fair amount of time before that happens, but we're able to make it useful right now because Zhu has, and his students have created a software ecosystem that does use GMNS as it is. So it's kind of like we're in the early stages. This is the first step, but I think in the long term, it would be nice to like remove these barriers with a proprietary format. But obviously, there's work to do to do that, to sync up the
Yep.
differences.
And what related to that? Sorry, Lisa, I'm gonna then I'll move over to Scott. So sorry to, but there's there's no issue with some of the software vendors, right? Because they're just it's just an open exchange format.
Right,
So
right,
there's
right.
okay,
So similar to how when GTFS became available, a lot of software vendors created import tools for GTFS
yeah,
so that you could import a GTFS network. It's, in the long run, and ideally GMNS would become that for the roadway side.
okay. Scott, I know there's a couple of questions that I think you're probably best suited to answer. The first one was does GMNS currently have capability, or is it planned to have capability to incorporate information from, say, OpenStreetMap?
Oh, well, thanks to Simon's team, yes. There are, yeah, there's actually a tool, OSM2 GMNS, that basically makes a GMNS network from OpenStreetMap, and we've used it quite a bit, actually, in some of our own products. So yeah, yes. Get out
Okay.
one.
And I would
And
also add that the Network Wrangler tool,
Yeah,
like that's been a big focus of it too, is
yeah,
providing a library to, create networks. So one of
yeah,
the primary common sources for creating a network at this
yeah,
point is
yeah.
OpenStreetMap.
oh,
So that'll also be talked about in probably excruciating depth at the other learning session.
Yeah. Uh,
yeah, that's
Nadine,
October.
can I jump in on the future roadmap question?
I was about to do. There was a question about what does the future roadmap for GMNS look like, and what does it plan to accomplish? So,
Okay, so
Scott.
I think as Lisa said, we're in early stages. We're trying to get kind of the critical mass where vendors start having interest. Um, and I think the future roadmap, to a large degree, depends on the people who are using it. There are, you know, I So it's kind of like a little bit of the GTS philosophy. We're not going to make changes just to make changes. We will make changes in response to a real need that a user expresses. Um, Two of the things that we're looking at right now is one thing is encapsulation of networks. This came out of Billy Charlton's presentation last September. It said, yes, makes sense. So yeah, we can just fine with having a GMNS network encapsulated, say, in a spatial light database. And we're starting to do that for our larger applications rather than a pile of CSVs. That's fine. Other thing we're beginning to explore now for partners at Federal Highway is getting into the AGIST world and state DOT networks that they use for reporting HPMS is like how can we bring some of that into GMNS?
Mm,
We're just beginning to explore that. Two examples of what we're looking at now.
okay. Um, Getting to the end of the questions. So if there's any other questions you'd like to ask, feel free to use the Q&A chat bot. It's at the bottom toolbar of your Zoom window. Um, I think, Mohammed, I think one of your slides, there's a question about noticing any significant difference of the original AM peak assignment and the GMNS assignment. Um, so Mohammed, I think it was your slide 8 talked about that, but I'm just scanning your slide deck really quickly. So the question is there any significant difference of when you use, the original assignment, AM peak versus after you did GMNS conversion and ran the assignment?
So, so we haven't captured all the demand from the ARC yet. So there are still some modes left to be modeled. But the modes we modeled, it is the ratio is very close to one. So basically, for the static assignment, we could completely replicate the AM peak as far as it goes for those modes we could model. And I
Okay.
cannot answer for the full model because we haven't
Yeah.
modeled the
Yeah, it was just
complete. Yeah.
yeah, it was just AM peak. Okay.
Yeah.
Um, Scott, I think the two next questions are kind of in your territory, but Simon, Lisa, if anybody else wants to jump in. But um, one of the participants says that talks about, they are essentially maintaining two different networks, a regional and one for regional modeling and one for DTA, and that obviously is very cumbersome. And do you see, or do you see GMNS kind of being a help in only keeping one network, and then being able to send it to the appropriate analytical tool?
Uh, yes, I think if you're a little careful now you may want differing levels of detail, and OpenStreetMap was fairly smart about this, where you may for the larger network have, maybe just go down to arterial or collector functional class and then go down all the way to all roads for the more detailed modeling. That's possible. You just have to be a little careful to make sure you don't disconnect your network. Uh, and so I think and at the next level is, we start with node link, but then we have capability to do detailed modeling of intersections. So, for a static model, you might just use the node link, and then if you want to do simulation, then you start bringing in the movements and the intersections in lanes and so on.
Okay. And when you mentioned HPMS, that got some attention. Could you explain that use case a little bit
Sure.
more that you had referenced?
Yeah, it's very early stages. I think a while ago. Well, let me give some background. So states are, expected to report highway performance monitoring, expected to bring in statewide networks and report a sample to federal highway.
Hmm.
Um, and so state DOTs pretty much all have statewide networks, though there are varying degrees of routability and really coming from the linear referencing world, where you're looking at maintaining these assets and not routing on them. So it's really a very different origin, um, as opposed, but it's good data. It's probably more authoritative than OpenStreetMap, whose quality varies widely.
Hmm.
So one thing I just had an intern exploring this summer. Okay, let's take some state data and see what's involved in making the GMNS network out of it. And that is, breaking up the links at the intersections properly and seeing what that offers and what you can make for lanes out of it and the like. Uh, Early stages, not particularly easy, but I think we feel that, having a better capability along those lines will help a lot.
Thank you so much. Thanks, Joe. Just a reminder to, in about 1 minute, we'll be showing up in the Zephyr Lounge. Um, Chairs are optional. So you can access the lounge by either using the QR code or the link shown on the screen, and we'll be there in about a minute or two. We've gone through all the questions, so we really appreciate everyone asking questions about this topic, and we especially want to thank our speakers, Ashkan, Guy, and Mohammed. Thank you very much. Really appreciate that. So I think with that. Joe, I think we'll call this and we'll all migrate with over to the lounge.
All right. Thank you, everybody.
Thanks, everybody. Have a great day.